So in this video we'll see the formulas that is related to the first chapter of CBSE 11th grade chemistry. There is some basic concepts. These are the high yield formulas which will be very helpful in solving most of the numericals. Okay, first we'll begin with the basic formula. What is density? Density is equal to mass by volume. Okay, so we can learn the conversions also. So you all know that temperature can be expressed in 3 units, that is Kelvin, Celsius and Fahrenheit. Okay, so we should know how we can convert these three. Okay, like if they are given in Kelvin, you should know how to convert it into Celsius and Fahrenheit, and if they are given in Celsius and Fahrenheit, you should know how to convert it into Kelvin. Mostly in the sums you have to use the Kelvin only, so that in the question if you have Celsius and Fahrenheit, you will be wanting to convert it into Kelvin. Okay, so for that you should know the formulas. So Kelvin is equal to 273.15 plus degrees Celsius. Okay, and Fahrenheit is equal to 32 plus 9 by 5 degrees Celsius. Okay, so this is the formula to interchange Kelvin, Fahrenheit and Celsius. So next we will go into another important concept, that is AMU. So what is the value of AMU? So AMU is equal to 1.66 into 10 to the power 24. Okay, the value of AMU is 1.66 into 10 to the power 24 gram. Actually, what is AMU? AMU is 1 by 12th mass of 1 C12 atom, which can also be written as 1 by Avogadro number. So what is the value of Avogadro number? It's 6.023 into 10 to the power 23, right? So 1 by 6.023 into 10 to the power 23 will give you the value of AMU, that is 1.66 into 10 to the power 24 gram. Okay, so next we will see how to find molecular mass. Okay, so how will you find molecular mass? Molecular mass is actually equal to N1 into M1 plus N2 into M2 and so on. So what does this imply? For example, you have CH4. Okay, how will you find out the molecular mass for CH4? So first consider C. How many atoms of C is there? 1, right? So 1 into, what is the weight of carbon? It's, what is the weight of carbon? That is, what is the molar mass of carbon? It's 12, right? Plus how many hydrogen is there? 4. And what is the mass of hydrogen? It's 1, right? So you'll get 12 plus 4. So the molecular mass of CH4 will be 16. Okay, this is how we have to find the molecular mass, and this is a formula of molecular mass. Okay, next we will move into finding the number of moles. To find the number of moles, there are many formulas, and you have to choose which formula you will be using depending upon the situation. Okay, in case they are given masses, you have to use this formula, that is given mass divided by molar mass. In case they have given the number of particles, then it is number of particles divided by Avogadro number. Okay, in case they have given volume, it will be volume given divided by molar volume. So what is molar volume? Molar volume is the volume occupied by 1 mole of a gas. Okay, so what is the value of molar volume? Molar volume can be 22.4 or 22.7. Okay, it can be 22.4 liters or 22.7 liters. So at which conditions it will be 22.4 and under which conditions it will be 22.7, that you should know. Okay, so in the standard conditions, when it is 1 atmospheric pressure, 0 degrees Celsius and 273 Kelvin, the molar volume will be 22.4 liters. Okay, when it is 1 bar pressure, 0 degrees Celsius and 273 Kelvin, the molar volume will be 22.7 liters. Okay, so when it's 1 atmospheric pressure, it will be 22.4 liters, and when it's 1 bar, it will be 22.7 liters. So next, moving on to the next concept, it's average atomic mass of isotopic mixture. Okay, for isotopes, how will you find the average atomic mass? The average atomic mass will be equal to A plus M2B divided by A plus B. Here, in case they have given a number of isotopes, for example, chlorine, consider chlorine, it has 2 isotopes, right? So M1 is the mass of the first isotope and M2 is the mass of the second isotope. So what is A and B here? They'll give you, like chlorine, the first isotope of chlorine occupies 9% and the second isotope occupies 91%. Okay, so this A is the 9%, that is A is the percentage abundance of the first isotope, that is of the isotope which has mass M1. Okay, of isotope which has mass M1, and B is the percentage abundance of the isotope which has mass M2. Okay, if they are given the abundance in percentage, you have to use this formula. In case they have given the abundance in fraction, like they have given the abundance like 1 by 2, 1 by 5, like that they have given 4 by 5 and 1 by 5. If they have given the abundance as fraction, the formula which you have to use is M1 F1 plus M2 F2 plus M3 F3. So what is M here? M is the mass, and what is F1 here? F1 will be the fraction of the isotope which has mass M1. Okay, so if you have given in fraction, you have to use this formula, and if they are given in percentage, you have to use that formula. Okay, so next we'll move on to mole fraction. Okay, so what is the mole fraction of a component in a mixture? Okay, so consider a mixture contains 2 components. Okay, a mixture is there, and here there are 2 components, that is A and B. You have to find what is the mole fraction of A and what is the mole fraction of B. So what is the mole fraction of A? Mole fraction of A will be number of moles of A divided by number of moles of A plus number of moles of B, that is the total number of moles. Okay, that is the number of moles of the component for which you are finding the mole fraction divided by the total number of moles. So similarly, what is the mole fraction of B? It will be NB divided by Na plus Nb, right? So when you are adding the mole fraction of both, what will you get? Will be Na plus Nb divided by Na plus Nb, and it will be equal to 1. So from this, what can you understand? The sum of the mole fractions of all components present in a mixture will be equal to 1. In case this mixture consists of 3 components like A, B and C, so you will be getting mole fraction of A plus mole fraction of B plus mole fraction of C is equal to 1. Okay, the sum of everything, every component present in the mixture, that is the sum of the mole fraction of every component that is present in the mixture will be coming to be 1. So the next concept, how will you find mass percentage of an element? So what is the formula to find mass percentage? Mass percentage of an element is equal to mass of the element divided by molar mass of the compound into 100. Okay, into 100. For example, I'll give you the same example of CH4. I'll give you. What they'll ask is that we already found the molar mass of CH4 as, what did we find? We found it to be 16, right? So they'll ask you what is the mass percentage of carbon here. So what is the mass of carbon? You know the mass of carbon is 12, and what is the molar mass of this compound? The molar mass is 16 into 100. So this is how we will be finding the mass percentage of an element in a compound. Okay. So the next is, we'll see about empirical factor. Okay, what is empirical factor? when doing sums related to empirical formula, once you find out the empirical formula, you should multiply it by one number to get the molecular formula. Okay, that is the empirical factor. What is the value of the empirical factor is that it will be molar mass divided by empirical formula mass. Okay, molar mass divided by empirical formula mass gives you the empirical factor. So next, let's go to formulas related to concentration. Okay, so what is the mass percentage of a solute? Mass percentage or weight percentage of a solute. What do you call this? What will you get for this? It is mass of solute divided by mass of solution into 100. Okay, so how will you identify the concentration in ppm? The formula of concentration in ppm is mass of solute divided by mass of solution into 10 to the power 6. Okay, they can directly ask you, like they'll give you the mass of the solute and they'll give you the mass of the solution also, and they'll ask you what is the concentration of a solute in ppm. Okay, so already it has been asked in one previous year. By using this formula, you have to solve that. So next is molarity. So how will you find the molarity? Molarity is actually equal to number of moles of a solute divided by volume of solution in dm cube. Okay, we should make sure the value is in dm cube. So what is the formula of number of moles? Number of moles has another formula also, which is mass divided by molecular mass. Okay, molecular mass. So here for number of moles we have substituted mass divided by molecular mass. Mass of what? Mass of solute. Okay, because here we have number of moles of solute, no? So it's mass of solute divided by molecular mass into this volume of solution in dm cube. Okay, so this is a formula of molarity, and molarity is expressed in capital M. So you should also remember this, m1 v1 is equal to m2 v2. Where you will use this formula is that they'll give you the molarity and they'll give you the volume also. One solution has, for example, they'll give you one solution has 500 ml and the molarity is 0.5 m, and they'll tell you have to from this solution you have to prepare another solution which is of molarity 1 m. For that, how much amount of volume will you use? They'll ask like this. For that, you have to use this formula. Okay, they'll give you a solution, the molarity of the solution and the volume that the solution contains, and they'll tell you from this solution you have to prepare another solution which is 1 molar, and to prepare the solution which is 1 molar, how much volume will you use? That will be the question, and you have to use this formula to find out that. So next, moving on to the molality. So how will you express molality? Molality is actually expressed in small m. Okay, what is the value of molality? It's number of moles of solute divided by mass of solvent in kilogram. Okay, next, how will you find the percentage purity? This also has been asked in previous year. Finding the percentage purity. Percentage purity should be found out by mass of pure component divided by mass of impure component into 100. Okay, this is also an important formula. It has been asked before. So next is, how will you find the percentage yield? So how will you find the percentage yield? I'm compressing these formulas because they have asked in previous years. Okay, percentage yield is equal to actual yield divided by theoretical yield into 100. Okay, so we have almost covered every formulas of this chapter. Okay, one thing which is remaining is vapor density. Okay, vapor density. What is the formula of vapor density? Vapor density is equal to density of a gas divided by density of hydrogen at the same temperature and pressure. Okay, that is the density of the gas at a temperature and pressure, and then divided by the density of hydrogen at the same temperature and pressure. Okay, there is a formula which links vapor density and molecular weight. It's 2 into vapor density is equal to molecular weight. Okay, so this is also a very important formula. So I hope we have covered all the formulas in this chapter. Just revise these formulas, take it down, take these formulas in a note, keep on revising this, keep these formulas at the base, and solve as many as numericals possible, and it will help you gain more knowledge in this chapter. Okay, thank you.